Okay, so there's the second part of the second lesson, lesson two. I'll probably mark lesson three, whatever. I'll decide later. But for now, earlier on we spoke about events, not so. Okay, we first marked the exercise 17.1 and 2. Now we're looking at examples for exercise 17.3. I think we stopped here. Huh? The intersection and union sets. So let's just go through it again from the top. I know at that point you guys were a bit tired already. So in a hat there are cards numbered 1 to 10. As we know there are 10 cards now. The sample space is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. They say consider the events drawing. So X is the factors of 6. So the factors of 6 from this set of numbers is 1, 2, 3, 6. People, if 6 was not part of this number set, I wouldn't have listed. Okay, because it's from the sample space. Does it make sense? Right. So, and then Y was drawing a factor of 9. So to list the factors of 9 is 1, 3, and 9. Okay. So, we said that what is the number in X, in subset X, is 4. And we said what is the number in Y? 3. Okay. So also we spoke about the union of two sets is all the elements in set X or in Y, or in both X and Y. Okay. So if you're looking at X union Y, if I list that, we know it's first going to be 1, 2, 3, and 6, and 9. Okay, you all agree with that? I'm not going to write 1 and 3 again because we are already considering those elements. What is the number of X union Y? X or Y? They are 5. You guys understand? Now we're looking at the intersection or the upside down end. The intersection of the sets is all the elements that are in both X and Y. So which element is in X intersection Y? So the only number that is in both is 1 and 3. Can you see that? So in X intersection Y, it's going to be 1 and 3. So what is the number in X intersection Y? Do you guys understand? Okay. So that's what they explain here. Hopefully we can draw a Venn diagram. If I should have drawn, and I know this is not the question at this point, but if I must draw a Venn diagram for this information. So the sample space, normally I put it in a circle, not so. So for now, my sample space from now onwards, I can put in a little box. Okay, you can make the circle if you that kind of go, but the circle box is same. We call this S for the sample space. So is there an intersection over X and Y? Is X and Y joined or disjoint? Joined. So there is an intersection. Do I draw? This said X and that is said Y. So the first thing we draw in is what is in both sets? 1 and 3. So 1 and 3 goes here. Can you see that? So it's from set X and set Y. So if we're looking at X, what is left out? 2 and 6. So here will be 2 and 6 here. Okay. What is in Y only? 9. So what did we not account for? There's 1 2, 3, 4 is not accounted for. So it will go out on the outside of those two sets. Although it's still part of the sample space, it is not part of um, of event X or event Y. Can you see that? So where's 5? Also not there. 5. 6 is here. 7, 8, 9, and 10 is not here. But there's 10 numbers here. Can you see? So the sample space, all these numbers are now accounted for here. Is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So the sample space has everything. Yes, Michael? As long as it's the intersection and so on. So she said, can you put 4 here? Yes. Instead of the yes. Okay. Okay. Anything else? But that will still come up. I'll just show you what needs to come. Okay. So let's look at an example. This example is on page 383. Okay. Cards numbered 1 to 8 are placed in an open box. A card is drawn at random. Use a set notation to list the sample space. So what would that be? The sample space would be 1, 2, 3, 4, 5, 6, 7, and 8. Okay, let's look at B. Use set notation to describe the event O of drawing an odd number. So O would be 1, 3, 5. Will you guys understand? Any confusion? Okay. Let's carry on. C. I think I pulled this out. Okay. So now we are told in C, use set notation to describe the event E of drawing an even number. So even number is 2, 4, 6, and 8. Okay. D, right? The event O, odd, union E, even in the set notation. So it is all the elements that belongs to O or E. Not so. So what are the odd numbers? 1, 3, 5, 7. Even numbers? 2, 4, 6, 8. So what do you notice? It's exactly the same as the sample space. Yes, Michael?
So it doesn't have to be put in order like 1, 2, 3, 4.
It doesn't have to be in order. I said that in the earlier one as well. And I think you asked exactly the same question. So the order doesn't matter here. But if you want to put it in order, it's going to be better for you if you are scared you're going to miss out on a number. Okay, again, we do not repeat a number. Okay? That is D. Let's look at E. E says, the people that's talking in the background, please stop it. It's irritating. Question E says, write the events O intersection E in set notation. So that is the intersection. Intersection means to say it must it must, then the element must belong to both sets or both events. Which element belongs to both these events? Does 2 belong to both? 8? No. Is there any? No. So to represent this, it's either you write empty space. We can't put a 0 because 0 could later on represent an element. Not so. Because if the sample space was different, say you're listing the sample space from 0 to 10, then 0 would have been an element. Not so. So we don't put 0 in, so we put an empty space, or we put 0 with a line through, which means to say nothing. Okay. So make a note of that. That if it's 0, it will be an empty space. Or 0 with a line through it. Okay. So let's look at if. Number 1. If 1, they ask you to list, okay, number 1, the number in the sample space. How many is in the sample space? 8. Can you see that? Number 2, the number of elements in the odd set. Sorry? 4. The number in event E. 4. The number of odd union E. 8. And then lastly, the number of 0 intersection E is nothing, so 0. Okay. Is there any confusion there? Alright. So let's look at the next question. The next question says, represent S, sample space, E, even numbers, and O as a single Venn diagram. Now, are events O and E joint or disjoint? Disjoint. So will there be an overlap or no overlap? No overlap. So when I draw the Venn diagram, I draw it without the overlap. Does it make sense? Okay, so I'm going to pull this down here. So what did we say for the Venn diagram? We're going to make a box. That's your sample space. Not so? Okay. So we have 2 subsets or events. One being, I'm going to make it a bit bigger because I have the numbers of few. E and O, sample space. Even if I draw this, okay, I'm going to show you what it's going to look like if I initially draw it overlapping. Okay. So that will come back to now. So represent SE and O as a single Venn diagram. So what elements is in E? 2, 4, 6, and 8. What elements are in odd? 1, 3, 5, and 7. And there's the Venn diagram. Is there anything on the outside? No. Why? Because all the numbers is accounted for in the subset, sorry. Did you see that? When this happens, if there's nothing on the outside, there's a special name for this as well. And you call this exhaustive. Yeah, but then we'll get that word later on again. Okay, it's exhaustive. Which means to say all the elements is used in the subsets. There's nothing on the outside. Okay. You go with that sample space on the side. These sets are also what they say complementary. Which means to say they add up to the sample space. Okay? But again that those terminology will come out later. So you sample space, you got E and you got S. No, sorry, O. So even numbers is 2, 4, 6, and 8. Sample space 1, 3, 5, and 7. Are events E and O joint or disjoint? Even though it's overlapping there, there's no common element between the two sets, therefore disjoint. And disjoint is also, the name I said earlier on, mutually exclusive. Okay? Right. Let's look at the next example. And this example is on page 384. Okay. Card numbers 1 to 12 are placed in a hat. A card is withdrawn at random from that. Question A says, give the sample space S in set notation. So what would this be? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay. Represent the event P of drawing a prime number from that in set notation. People, what are prime numbers? Numbers that only has two factors, one in itself. Such numbers from numbers 1 to 12 are 2, 2, 3, 5, 7, 11. Although 13 is also a prime number, it is not from the sample space where the numbers to select from. Okay? 2 is also your only even prime number. Okay? Let's look at C. Represent event F of drawing a factor of 12 in set notation. Factors of 12 is 1, 2, 3, 4, 6, and 12. Okay. You all understand? Right. Let's look at D. Sorry. D says represent event P union F of drawing a prime number with a factor of 12 in set notation. Okay? So P union F. So what is the rule for union? It is elements of both sets. Okay? And do not repeat, he says. So P and F, so it's going to be 1, 2, 3, 4, 5, 6, 7, 11, 12. As you can see, there's no 8 in these two sets. No 8. There's no 9. Now skip the 9. No, not supposed to be written. Eh? No 9, no 10. There is 11 and a 12. Okay. E. Represent the event P intersection F. What's the rule for intersection? The elements must be in both events. Awesome. So what is in both? 2, 3. That's it. 2 and 3. So would this sets be joined or disjoined? Joined. Why? Because there is common elements in those sets. Okay. Draw a Venn diagram. Okay, so let's draw the Venn diagram. Again, draw a box. Sample space. We got, are they joined or disjoined? We say there they are. Joined. So I put P and an F. So what goes in the middle? 2 and 3. The overlap is 2 and 3. I normally do that first, so that I don't put 2 and 3 somewhere else. Okay. So from P union F. Right, so now we need what is from set P and what is from set F now. Okay. Right. So what is in P? P only. Remember, we have accounted for 2 and 3. Can you see that? So you write 5, 7, and 11. Okay. For set F, we accounted for 2 and 3. So what must be written? 1, 4, 6, and 2. Now let's see what is not accounted for. Remember, the sample space are numbers 1 to 12. So we got 1, 2, 3, 4, 5, 6, 7. 8 is not accounted for. 9, 10, and 11 is not accounted for. Okay, it is accounted. Nice. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11 and 12 is accounted. Okay. You all okay with that? Right. That was question F. Let's look at G. G says list. In the first case, the number of P and F. Okay. So how many is what does it mean? The number. So how many is in P intersection F? So this space is the overlap, the intersection. So how many elements are there? 2. The answer is 2. Okay. Then he says G2. The number of P or F. O is also the union. So make a note there. The day we did make this note. We made the note. That the O is going to be union. and is intersection. Okay, so the number of if all p, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So there will be 9 out 9. Okay, 9 out of the 12 numbers are belonging to in union for pre-union if. Okay, or P or if. Okay. Is there anybody that's confused there? Okay. So what that you should be able to do, exercise 17.3. In exercise 17.3, I want you guys to do, just take this one here. In 17.3, I want you guys to do number one, 3, 5, 7, 1, 3, 5, 7. Okay. Let's start now. And whatever is left is for homework. Okay. And then in our next lesson, we will answer these questions in a video. Okay.